In demonstration 6, we will sketch and extrude a shape that requires the use of collinear and concentric features. In sketch mode, we will be using the line command, arc, circle command, the collinear, tangent and concentric constraints. We'll also be using the fillet command. We'll be applying various dimensions as required and then using the coincident constraint before finally moving into the 3D environment where we will extrude a selected profile to give us the final form. Start the exercise by opening a new part file using the standard millimeter IPT template from inside the metric templates folder. We now have to start a 2D sketch, our first 2D sketch, and we'll select one of the origin planes to place that on. And now we're going to use the line command to start drawing the basic outline of the object that we need to create. So I'm going to simply put some lines in here, bearing in mind that a number of the radiuses and such can be added later on using the fillet command. So making sure I'm using the automatic constraints where they're applicable, and I've used the lines to create some of the part of the basic outline of the object. I'll now use the arc command, and I can snap arcs to various places, and you see that when I added that arc, it actually added automatic tangent constraints, and depending on how the arc is placed, you can see the constraints will light up there. That means I don't have to then manually apply those constraints later on. Just make sure you actually want them to be tangent. So I didn't get any tangent constraints on that one, so I'll now use the tangent constraint to apply to those two. And we're starting to get the basic shape. I can now apply a circle, and I'll just draw a circle in here. So we can snap circles to existing center points, which will make those 2 points coincident. One of the other options we've got, as well as making center points coincident, which we can do here, so coincident point to point, we've also got the concentric constraint. The concentric constraint works really well when you're dealing with radiuses, large radiuses, and arcs, because it's not necessarily easy to find or select the center point that's involved. So I've now got those on. We can also use the equals constraint to make our radiuses equal. So those three radiuses now equal, and I'll also use the equals constraint to get the same diameters on each of those circles. So when I start adding dimensions, the first dimension I add will scale up the entire object. So this is a radius dimension that's being added because that's an arc. In this particular situation, our radius needs to be 20. So that scales up the entire object. Now I'll add a diameter dimension to the circle that's drawn at that center point, and that needs to be 20 also. And you'll see that those two dimensions have resized these other ones as well. If I want to relocate just the number of a dimension, I just click on the number itself, and I can drag the dimension around without affecting the actual value. Now we'll need to start adding some dimensions, other dimensions here. So our center point to center point dimension is 150 millimeters. And you'll see that this has actually caused a problem in here. Now sometimes that dimension needs to be removed and Control Z or undo to go back a step. But the other option we've got here is to get out of the dimension command and then just drag that line back so it's roughly in the right spot. And obviously this is indicating that we now need to place a dimension on that as well. So I'll place a dimension between that line, and that needs to be of 30 millimeters. One of the other things that we'll see here, that even though these lines are the same distance apart because the radius of that arc is the same as this one here, so the spacing top to bottom is the same both sides, we've got this variation here. Now this can be very easily overcome using the collinear constraint. The collinear constraint means that any two straight lines that are selected will then exist on the same lineal path. That doesn't mean that they have to overlap or that they mustn't overlap, but they will align with each other along the same lineal path. So that constrains a lot of that. Now, one of the other things that we can do here is we'll use another dimension from center point to center point in order to put this guy in the center, and according to our exercise that's 75 millimeters. And we can also place a dimension between our bottom line here and the center point of that circle, also 75 mil, in order to place that. Now we can see down the bottom here that we've still got 4 dimensions needed. Now 2 of those dimensions are going to be the dimensions needed to locate this in space. So there's still a couple more to go. Now one of those is going to be in order to position this. Now because this feature here needs to be in the middle, what I can use is the equals constraint and to make that line equal in length to that line. And that actually puts that in position for us. Now we're going to have the same sort of issue here as well. And I'll try and add a constraint to that as well. So if I add an equals constraint to here and here, it's having a think about it for a moment, so it's likely to come back with an error message, and I suspect it'll say that adding this constraint will over-constrain the sketch. That means that that constraint is not necessary. It doesn't already exist, it just means that it's not necessary because something else is taking care of it, and that would actually be these 2 dimensions here that are taking care of that one. So somewhere in here we've got another constraint that needs to be found. So what I'll do in order to try and locate, and I've just worked out what it is. It's the position of that line there. So what I'm going to do here is put a 20 millimeter dimension on that. Okay, 2 dimensions still needed according to our little note down here in the bottom right. I'm going to use the coincident constraint just to constrain the object back to our origin point, and that is now fully constrained. We haven't quite finished yet. We still have to use the fillet command. So fillet, we've got a couple of different radiuses to apply here. The ones down the bottom are 5 millimeter radiuses. So I'll make that a 5 and then pick one line then the other and then the other side. They're done and applied. Now I need to use 10 for that radius and that radius, and you'll see that it applies the dimension to 1 and then it automatically applies the equals constraint between the 2 arcs and also applies the tangent constraints either side, and that's all done automatically, making the fillet command certainly a very useful one. So there's our shape, fully constrained, finished sketch, and now that we're in the 3D mode we need to extrude. Our distance that we're going to extrude is 12, and because again there is a number of different profiles, we need to make sure that we pick the correct profile. Now if at any stage we pick the wrong profile, holding down the shift key and reselecting it will unselect it. So we click the profile that we want, make sure that the distance is as required, and then click OK, and that finishes this particular form.